With a lot of integral examples, it initially doesn't look like any of our traditional rules fit. So what we have to do quite often is rewrite the integrand so that it does fit one of the few rules that we do have. Now, when you have trig functions, a lot of times what you'll need is a trig identity. And so it's a good idea, even though you're in Calc 1 or Calc 2, to always go back occasionally and review your pre-calculus notes or your trigonometry notes where you first studied trig identities such as sine squared plus cosine squared equals 1. That's one that a lot of people know, but there's others as well. Sine of 2x equals 2 sine x cosine x, and so on and so forth. There's probably maybe 15 or so trig identities that we should be able to recall at any time. And I know that sounds like a lot, but the more you know, the easier Calc 1 and Calc 2 and Calculus 3 will be, because you've got those in your back pocket. And so here's a good example of how this could be a big help. We're asked to integrate tan squared x. And right off the bat, just in a general sense, I can't think of any function whose derivative would be tan squared, which would be the definition of the integral of tan squared is somebody whose derivative would give you tangent squared. There's just nobody I can easily think of that would do such a thing. You might try rewriting it like sine squared over cosine squared, but that's really not any better. And you could try lots of different options. But one thing that I can think of is I remember that tan squared, by definition, this was a trig identity, was equal to secant squared minus 1. Now, why would I prefer to write it that way? If instead of writing integral of tan squared, if we wrote the integral of secant squared theta minus 1 d theta, the reason I would prefer this is I could integrate secant squared. That actually has a pretty nice integral. And I can integrate 1. That has a pretty nice integral. So by using a trig identity, I would get as my final answer, I would get tan theta, because the integral of secant squared is tangent, and minus, and then this would be a theta. This would be a theta right here, because that's the integral of 1 with respect to theta with a plus c. And so this is a very typical example. You'll oftentimes have a trig function in your integrand that doesn't exactly fit one of your basic rules. And so with a quick little rewrite, whether it be with a trig identity or something like that, then you suddenly change it into a format that you can integrate it. And again, this just comes with practice. There's really no other way to get good at these other than practice lots and lots of examples. But hopefully in time, if you practice enough examples, you shouldn't have any trouble with these.